Everyone. In the previous part, we had gone through the topic called paper chromatography. Now, in this part, we are going to discuss about the topic called TLC. So, what do you mean by TLC? Thin layer chromatography. So, before going into the topic of thin layer chromatography, let's have a quick review of the types of chromatography. So, as I told you, principally these are being categorized into two types: adsorption chromatography, partition chromatography. So, adsorption chromatography, you are going to have this stationary phase as a solid, and in the partition you're having the stationary phase as a liquid. But coming to the mobile phase, it can be a liquid or gas, or here also it can be a liquid or gas. So this partition chromatography, depending upon the liquid or the gas mobile phase, again being classified into different types. So depending upon the mobile phase and the stationary phase, liquid, we are having the partition column chromatography, partition thin layer chromatography, paper chromatography, and HPLC, high performance liquid chromatography. So in the previous part we have discussed about this paper chromatography, and now we are going to discuss about this partition type, that is where the mobile phase as well as the stationary phase are liquids. Okay, so let's go into this one. So thin layer chromatography, if the separation of compounds or molecules are done on a thin layer, it is being termed as thin layer chromatography. And this thin layer chromatography was introduced by recently by Ijmailov and Williams. So these are the two scientists who recently introduced this thin layer chromatography. And they achieved some success with adsorbents plated out on a glass surface. So rather than packed in the column. In this chromatography, that is thin layer chromatography, a glass plate coated with an adsorbent is used as a substitute of a paper. In the previous paper chromatography, we used the paper as an adsorbent, but here we are using a thin layer. Okay. Now, coming to the principle, the same principle what we have discussed in the paper chromatography. So here is a retardation factor. So the relative or the ratio of the distance traveled by the solute divided by distance traveled by the solvent front is going to be called as retardation factor, and I told you this retardation factor value is a constant for a given compound under standard conditions and temperatures, and these are the few examples of those retardation factor values. Okay, then coming to the procedure of this thin layer chromatography. So this is how the thin layer chromatography. So major difference you have to keep in mind is in the paper chromatography we'll use the paper, and in the thin layer we are going to take a glass slide containing the adsorbent made up of silica gel or aluminum powder. Okay, and now we will discuss about it. So you are supposed to take a glass plate coated with an adsorbent, which is a substitute of a paper. A thin uniform film of adsorbent contains a binding medium, usually calcium sulfate, is spread evenly on a glass plate. And these plates were dried in the hot hour between 100 to 250 degrees centigrade to activate the plate. Now this activated plate was placed on a flat surface and the samples were spotted here. So samples were spotted, and then it is going to be dried for some time. So after the samples were dried, this plate was kept in the chromatography chamber containing the solvent. Now as usual you have to run the chamber, but here the time of running the chamber is going to be of only 5 to 30 minutes. But whereas in the paper chromatography it is about 6 to 8 hours or even more. So that's a major advantage of this one, where we can separate more samples within the less time. Okay, now after running of the chamber you have to take out the plate, you have to air dry it, and then you have to spray the spraying reagents. So what are the spraying reagents that we are going to use either in paper chromatography or in the thin layer chromatography are: for the amino acids we are going to use the ninhydrin reagent, and for the carbohydrates we are using the potassium permanganate. Okay, and potassium permanganate is mainly we are using it for developing the spots. Okay, or sometimes benzidine solution can also be used for the sugars, that is carbohydrates, either KMnO4, that is potassium permanganate, or the benzidine solutions are used for the identification of carbohydrates in the chromatography technique as a spraying reagent. Then what about the amino acids? It's nothing but the ninhydrin reagent. Okay, so here coming to your uh, or sometimes you can have the irradiation with the UV light, and in the UV light they are being shown like this, the spots. And as usual we are going to have the measurement of the solute travel and the measurement of the solvent front and their calculation, which gives the RF value of the concerned amino acid or a carbohydrate. So this is all about the procedure, how you are running the thin layer chromatography. Then moving to the applications of TLC. So obviously the TLC is a more advanced and it is also rapid technique, and it is more sensitive when compared to the paper chromatography. The reasons are, here it is taking only 5 to 30 minutes, not more than that, and we can complete so many samples under an hour, and a lower concentration of the samples can also be separated or detected by using this one. And this is also used, that is TLC, can also be used to identify drugs, contaminants and adulterants. Okay, and it has also been used to solvent plant extracts and many other biochemical preparations. And this TLC is a coincidence for superior to paper chromatography and column chromatography because of these following. So here are some of the reasons why it is going to have, sorry, here following specific reasons. The one, as I told you, the sharpest method when compared to your column and the paper, and it requires less amount of the sample, that is substance, and less time also, and it can tolerate to the acids safely, but this paper chromatography can't tolerate to the acids, and it can be heated to the high temperature where the paper can't be heated to the high temperature without any damage. So the individual parts are less diffused in on the paper, but here individual spots are less diffused on the TLC, but in the paper you will have the more diffusion. So that's also a drawback of in the paper chromatography. And it is possible to coat the plates with a variety of corrosive reagents also that would destroy the paper chromatography. So because of all these reasons, specific reasons, this TLC is going to be of a more advanced or widely used when compared to your, or it is a superior to the paper chromatography and the column chromatography. And paper chromatography is limited only to cellulose and other media as aluminum. And silica gel can't be used because they cannot be made into suitable shades. But this difficulty can be overcome in the TLC. Okay, and thin layers of these substances are put on plates which are known as chromatoplates. So those plates are being called as chromatoplates. Thus, the spread efficiency and sensitivity of TLC, that is thin layer chromatography, has made these techniques most valuable to the biochemists. Next, let's have a look on the difference between the paper chromatography and the thin layer chromatography. I told you already why the thin layer is superior to the paper chromatography. That I just want to mention it again such that you will remember well. So here is your thin layer chromatography and here is your paper chromatography. So obviously the first difference arises here is a paper, that Batman paper that we are using, and here we are using a thin layer. And then the solvent will be the same. Both are having a mobile phase liquid and the stationary phase is also liquid. And then separation of the mixture is very fast in the thin layer chromatography, whereas very slow in the paper chromatography. That's why we are running the chamber of about 6 to 8 hours, and here we are taking only about 5 to 30 minutes. Okay, and here it can tolerate, that is TLC can tolerate to corrosive reagents, high temperatures, acid sprays, everything, but where paper chromatography cannot tolerate to the acids, and it cannot be heated where it gets damaged by high temperatures and even with the corrosive reagents. So because of all these aspects, we can consider the TLC as a superior rather than this paper chromatography. Okay, so I hope so you have understood this thin layer chromatography well, and thus we are ending this chromatography topic with this TLC. Thank you.